All right, we went through law of sines, and guess what? There's law of cosines. So these are the formulas. So as mentioned, when we looked at law of sines, we had case 1 and 2 for law of sines. Case side, angle, side, and side, side, side are for law of cosines. And here are the formulas. So let's kind of see how they derive these formulas. If I take one of these triangles, and it doesn't matter which one, and I actually use the distance formula, say, to find C. So I know my distance formula is found. I can take C squared, and now I can take the differences in the x's, b minus a cosine C and square, and then plus the differences in the y's, 0 minus a sine C squared. So you may be used to the distance formula, C equals the square root, but we'll get to that part. All right, so from here, if I square this first term using FOIL, so I get b squared minus 2ab cosine C plus a squared cosine squared C. And then, of course, this last term, when I square it, is just going to become plus a squared sine squared C. All right, now from here I have c squared equals b squared minus 2ab cosine C, plus I'm going to actually factor out an a squared. So that's going to leave cosine squared C plus sine squared C. And hey, you remember that identity? Sure you do. This equals 1. So in other words, that kind of goes away. So changing up my order, a squared plus b squared minus 2ab cosine then of angle C. So not too bad of a proof. And so as you can see, what this next slide says is the square of one side of a triangle equals the sum of the squares of the other two sides minus twice the product times the cosine of the included angle. So they're kind of easy to remember because you have to have these sides, right? If you're solving for a squared. But what matches is your side and your angle on each one of these, and then the others variables are the other sides. So let's see if we can solve one of these. So again, just kind of drawing a ugly little triangle here. And let's call this our 60 degrees. So this becomes little c. Let's call this big B. So little b equals 3. And then we'll call that big A, and little a equals 2. Remember, when it says solve the triangle, it means just find all the missing values. So the first thing I'm going to do is I'm going to actually solve for C. And the reason that I'm going to solve for C, because if you remember, it has the angle opposite of it in the formula, and I have that value. So I'm going to have C squared equals my a squared, 2 squared, plus my b squared, minus 2 times my a times my b, and then times the cosine of 60 degrees. And if you work all this out, that will give you 13, 4 plus 9, and here you should get 12 and cosine 1/2. And so 13 minus 6, 7, and then let's square root it. So that gives me my answer for C. All right, now if I want to find A, well, I have this formula, a squared equals b squared plus c squared minus 2bc times cosine of A. And if I look at this, I know everything except A, so I could go through and do some algebra, of course. And so 2 squared equals 3 squared plus, we just found square root of 17, minus 2 times 3 square root of 17, and then cosine of A. All right, kind of getting things together. So 9 plus 7 minus 6 square roots. Why am I putting 17? And you're going, why is she putting 17? I don't know, 7. So square root of 7 cosine A. And so now I can kind of move things around. So of course I have, in fact, what I'm going to do is I'm going to move the 6 square roots of 7 cosine of A to the other side to make it positive. So then this side I'm going to have 16 minus 4, so 12. Then divide both sides by 6 square roots of 7, not 17. And I end up with, I can now just simply do the cosine inverse to solve for A. And the cosine inverse of 12 over 6 square roots of 7. And if you throw that in your calculator, I get about 40.9 degrees. All right, so that's that one, 40.9 degrees. So it looks like all we have left is B, easy, right? Because we just take and we subtract our angles from 180, and you should get 79.1 degrees. All right, so we'll continue on with another example in the next lecture.